Around 1500 CE, medieval German miners working in the silver mines came across a strange clump that was thought to be silver. However, once melted, it formed a bluish lump and left behind ill or death-ridden miners from toxic fumes. They dubbed this lump Cobalt, a mischievous goblin or imp spirit. In modern times, we know this lump or ore as cobalt. How did this goblin in the mines form? And why, despite its poisonous nature, is it snuck into everyday items from everywhere, including the palm of your hand? We need to go to the very beginning of the universe for stellar nuclear synthesis. Stellar nuclear synthesis, or nuclear fusion, is caused by extreme temperatures and pressure that fuses hydrogen and helium atoms and later forms heavier elements moving rapidly in massive stars or dense stars' cores. Energy is then released as atoms are being fused into iron is formed. Once iron builds up, the fusion stops with no more energy being released. This causes these stars to collapse and explode. This explosion causes rapid neutron capture or R process to occur, bombarding bursts of neutrons and transferring atoms. One of these atoms is iron-59, a heavy but unstable isotope that receives the neutrons and quickly undergoes beta-minus decay. The beta-minus decay process has the iron-59 isotope gaining one proton but loses one neutron to become the only stable cobalt isotope, cobalt-59. Besides cobalt-59, there are 28 unstable cobalt isotopes. As these cobalt isotopes form across the universe, how did they end up on Earth? Well, we need to go back to the formation of our solar system. Around 5 billion years ago, the solar system, including Earth, was formed when dust and star matter collected into a mass called a solar nebula. The solar nebula then collapsed under gravity forces, most likely formed by shock waves from the explosion of a dead star, a supernova. The collapsed material began rotating counterclockwise to flatten into a dish shape with most of the material in the center to form a protosun, the earliest stage of the sun formation. Our planets were then formed 4.56 billion years ago because of a large collection of dust and gas. Large amounts of magnesium, calcium, iron, and other metals found close to the sun will form Mercury, Venus, Earth, and Mars, while helium, hydrogen, and other reactive gases will form Jupiter, Saturn, Neptune, and Uranus. After forming, Earth then will have heavy materials sink to form its layers, including a heavy iron center, amongst other elements that will bind with the iron core. The mantle is formed from leftover elements, including cobalt. During the partial melting of the mantle that forms the crust, cobalt then will be mostly found in the lower continental crust, with some in the upper continental crust, such as the copper-cobalt deposits in Central African copper belt of the Democratic Republic of Congo. These deposits are part of the Nachanga granite, a type of sedimentary rock. Cobalite is the most common form of cobalt mined from these deposits. To mine for this cobalt, the major methods include mechanized or manual labor, based on mines and deposit types. Large companies own industrial mines and usually have machines to extract the cores, such as excavators, drills, and crushing equipment. The excavators and drills will take out the cobalt metal clumps while the crushing equipment will crush into smaller pieces. But this broken ore still requires some work because raw cobalt needs to be separated from the other metals. So we have these three processes to do that. We either heat up the ore in extreme temperatures based on metal properties, mixing the pieces with acid and high pressure before washing it with solution, or use different gases to separate the cobalt. Once you have cobalt, there are many uses for them, especially for smart technology. Cobalt is in the positive charge of lithium-ion batteries, the ones you use for your phone and electric vehicles. Cobalt makes the batteries have a stable power output, charge fast, keeps them from breaking under high heat, and has longer lifespans. That sounds neat, right? Cobalt simply rocks. However, we can't ignore the major human rights issues involved in getting cobalt. Since 1924, Congo had cobalt mining, making up 70% of the supply. There, most of the people are in artisanal or small and dip pit mines. Artisanal mines have intensive manual labor, with workers or diggers digging up the earth with pickaxes, shovels, or rebar to get the cobalt ores. That would mean diggers are surrounded by hazardous conditions, as cobalt is toxic to touch and breathe. Children also work alongside their parents to earn more money and support. The labor itself is intensive, for $1 or $2 as payment, and even called forced labor because of the work environment, equipment, and how they ended up working in the mine pits. For more information, read the book called Congo Red: How the Blood of the Congo Powers Our Lives. Phew, that was a lot. But now you know how and why cobalt is very important, from its disguise as silver to human benefit and human rights issues. So, if you're charging your phone or your computer, you can think cobalt, an important and tragic part of smart technology. Thank you for watching.